Okay.
And I can see your screen, Doug, so whenever you're ready.
Yeah, presentation mode. Here we go. Okay. In a sense, I'm kind of glad that you don't have a constellation of the month. This presentation is liable to run a bit long. So that's okay, I guess, right? Okay, so this is my presentation on women in astronomy. And I always start out with a comic strip thing. So this is this month's comedy, the Acme Black Hole Box. And by the way, if you have questions along the way, chirp up. I will answer questions as I go. You do not have to wait to the end of the presentation. Just chirp up and let me know. So when we think of the great names in astronomy, we're thinking of people like, well, Galileo, Tycho, Hubble, Carlo Shapley, Eratosthenes, the Greek, William Herschel. Those are kind of the names we always think of. And when you read your typical astronomy history, these are sort of names you pop up with others like Kepler and Newton. And but if you notice in this list of names, what we don't have, and that's any women. They're all men. And there are reasons for that, actually, logical reasons. For example, prior to the 19th century, it was very rare for a woman to get any kind of education beyond the very basics, what we'd consider grade school education. Anything beyond that for a woman was almost unheard of prior to the 1800s. Women were typically relegated to doing housework and other things and had no power, political or any other thing, and had very little control over their own lives, basically. Women got married and then they did the housework. The men went out and did whatever men did back then. I mean, if you look at it, women were not even admitted to Harvard University until 1936. You believe that? Cambridge University in England was a little better. They started admitting women in 1882. There were girls' schools all around the world, but the education you got out of those schools was not up to what you would consider university standards. If you went to one of those girls' schools, you might graduate with the equivalent of junior high or high school, but nothing more. They were not advanced. As a result, obviously, the careers for women were extremely restricted, relegated to women's work, that I put in quotes there. A perfect example is like even in the fields, even in some of the scientific fields like medicine. Okay, now medicine wasn't very advanced in the 1800s or 1700s, but you had doctors and you had nurses. Women were nurses, doctors were men, period. That's the way it was. Extremely rare to find a woman in science. Like basically, science was for the men. There were exceptions, which we'll cover some of those tonight, but that's the way the world was until the 1800s, basically. Things started to change during the 1800s, like I said, during the 19th century. Perfect example. Connor gave a really good lecture last month on William Herschel, and he mentioned his sister, Carolyn, and this is Carolyn Herschel, 1750 to 1858, so she lived a very long life. That can't be right, 108? I might have those dates wrong. But she lived a ripe old age. Carolyn started out just like any of the other women back then. She had a very difficult early life. She contracted typhus at age 10, which stunted her growth. She only grew to be 4'3" tall. Very small woman. It also caused her to be blind in her left eye. And just like most of the women of the day, she received nothing more than a cursory education, just learning to read and write, and that's all. Her family figured she would never marry because of her size and her blindness. And so they sent her off to be trained as a house servant. That's typical. When her father died, though, her brothers, William and Alexander, wanted her to join them in England because they wanted her to become a singer. Because William had actually been a singer at the church where he was, and they wanted her to join William as a singer because I guess she had a good voice. And so she did. She went to England, and on her way to England, she was introduced to astronomy by looking at the constellations. And for some reason, she toured some opticians' shops, and she started getting interested in astronomy. When she arrived in England, though, she still didn't do anything in astronomy. She took up her singing career, learned to sing. William and Caroline would develop musical careers. And probably had not William become interested in astronomy, Carolyn probably never would have, and they would have continued as musicians. But William started to get interested in astronomy and transformed himself from a musician to an astronomer. And Carolyn backed him up, basically. She said somewhat later in life, in her memoirs, she did nothing for my brother but a well-trained puppy dog would have done. That is, I did what he commanded me to do. Yeah. But she eventually became interested in astronomy herself and started picking up on interest. In the 1770s, as William got more interested, he started building his own telescopes because he was unhappy with what you could buy at the time. Carolyn would literally feed him and read to him while he ground mirrors or lenses. If you look at the picture on the right there, you can see him grinding away at a mirror, and she's preparing his food, and she's going to feed it to him 1 tablespoon at a time, if you like. During all this time, she picked up an education in astronomy, and she became a significant astronomer in her own right. Initially, she just performed the analysis on her brother's work, but later she began doing research on her own. On February 26, 1783, Carolyn made her first discovery. She found a nebula that was not included in the Messier catalog, and it's now known as Messier 110 or NGC 205. And it's the second companion of the Andromeda Galaxy. If you look in the image down on the bottom right, it's the one that's circled. And that was her first discovery. During the period from 1786 to 1797, she discovered 8 comets. In 1787, she was granted an annual salary of £50. Back then, that was a lot of money. That's equivalent to £6,400 in today's money. And this was granted to her by King George III for her work as William's assistant. Carolyn's appointment made her the first woman in England honored with an official government position, and she was the first woman to ever be paid for astronomical work. In 1797, William's observations had shown that there was a lot of discrepancies in the star catalog published by Flamsteed. Flamsteed's catalog was also very difficult to use because it was published in 2 volumes. And as I mentioned, it contained a lot of errors. William realized that he needed a better cross-index to explore the differences. but he didn't want to spend any time doing it. So he suggested that Carolyn take up the task. And she did. And it took her 20 months. And she came out with what was called the Catalog of Stars, taken from Mr. Flamstead's observations contained in the second volume of the Historia Celestis and not inserted in the British catalog. That's all one title. It was published by the Royal Society in 1798 and contained an index of every observation of every star made by Flamsteed. A list of it listed about 500 new nebulae and clusters to the already known 2,000. Toward the end of Carolyn's life, she arranged 2,500 nebulae clusters into zones of polar distances. The idea is she wanted her nephew, John Herschel, so that he could re-examine them in a nice, neat, orderly way. This list eventually became what was called the New General Catalog. And obviously today it's still heavily used. So you can thank Carolyn Herschel for the New General Catalog. So she had a nice career, but she started out, just like most of the women at the time, as a household servant. Her brother died in 1822. Carolyn moved back to Germany and continued her astronomical studies. She worked with her nephew, John. In 1828, the Royal Astronomical Society presented her with their gold medal for this work. No women would get this award again until 1996. Upon William's death, she took over observatory at Slough, which I think is in England. Carolyn had introduced John to astronomy with the constellation and Flamsteed's atlas. And Carolyn added her final entry to her observing book on the 31st of January, 1824, about the Great Comet, which had been discovered a few months earlier. Yeah, I did have the dates wrong. She died on January 9th, 1848. So she was 98 years old. And she's buried next to her parents in Germany with a lock of William's hair in her sarcophagus with her. Over her career with William and with John, she discovered over 2,400 astronomical objects. There's an asteroid named after her, using her given name. There's a crater on the moon named after her. And this one I thought was interesting. And one of these days I'm going to have to go to the museum where this is. I think this is at the either the Metropolitan Museum of Art in New York or someplace. There's a famous art object called the Dinner Party, which celebrates historical women who have made extraordinary contributions to different fields. And there is a place setting at the dinner party for Carolyn Herschel. All right, now here's another interesting woman, Mary Somerville. Oops, how can I get rid of this?
What are you trying to get rid of?
I've got a bar at the top of my screen that has mute, stop video, security, participants, new share, pause, etc. It's blocking the top inch of my screen and I can't read the title, for example. So like I don't see the date and stuff. Can I move that? Oh, I can move it. Never mind. I got it. There we go. Okay, so Mary Somerville, 1780 to 1872. Interesting how these lady astronomers live long lives. Look at this. She lived 92 years. Now, Lady Somerville was one of the exception women. She got a good education, mainly because she was the daughter of Vice Admiral Sir William George Fairfax, who is the heir to the family of Fairfaxes in England, which is a very big, important family. And she was also related to several Scottish houses of royalty through her mother. So having that kind of a heritage, basically royalty almost, allowed her to receive an education that women would not normally get. She became an expert in mathematics, physics, and astronomy. In 1835, she was elected, along with Carolyn Herschel, as the first female honorary members of the Royal Astronomical Society. Somerville was requested by Lord Brougham to translate a French book called Mécanique Céleste, which had been published by Laplace. In this book, Laplace had summed up all that had currently been known about gravity and basic mechanics and so forth. And that book was considered one of the greatest intellectual achievements since the Principia by Newton. But Somerville went way beyond just a simple translation. She actually expanded it and wrote a standalone exposition of the mathematics behind the workings of the solar system, in which she commented in her own work that she didn't just translate Laplace's work from algebra. What she did was she translated it from algebra into common language. Her translation was published in 1831 under the title of Mechanism of the Heavens, and she was immediately famous for it. And this book, Mechanism of the Heavens, was used as a textbook for undergraduate studies at the University of Cambridge into the 1880s. And there's a sample page from her book there. This doesn't work. Okay. Somerville was very passionate about astronomy and believed it to be a really good example of connection of physical sciences, in that it combined number, quantity, rest, motion, all in one field. Her second book, which was called On the Connection of Physical Sciences, eventually sold more than 15,000 copies and established her reputation as she's an elite scientist. Here's one of the more interesting things that I found about this woman. She was among one of the first people to actually predict that there might be a planet beyond Uranus. And this was long before they discovered Neptune. In her 6th edition of Connection, she wrote that quote there: "If after the lapse of years, the tables from the combination of numerous observations are inadequate to represent the motions of Uranus, the discrepancies may reveal the existence, nay, even the mass and orbit of a planet beyond this sphere of vision." And she was right. In 1846, Neptune was discovered. It was, and so on. The Connection book, this book here, quote on the right here, actually went into 10 different editions with more than 9,000 different copies eventually sold. And it became the most successful science book published by that publisher until The Origin of Species was published. And it was translated into German and Italian and went through various editions in the United States. She died in 1872 in Italy. There's a college in Oxford, England called Somerville College, named after her. She has an asteroid and a lunar crater named after her. Here's another interesting person. Now we're getting into the 1800s, but this is an American, Maria Mitchell, 1818 to 1889. She was born in a Quaker family in Nantucket, and because she was a Quaker, the Quakers valued education highly, and they insisted on giving her the same education that a boy would receive. So she got a very good education for the time. She pursued interest in mathematics and astronomy. And she got a good indoctrination into astronomy because her father was interested, or sorry, her father was interested in astronomy as well. Also interesting because Nantucket was a whaling port, which meant that many of the husbands were at sea for long periods of time. So the women would be left alone for many months, sometimes years. They had to learn how to manage the affairs of the house that the man would normally do. So the women in Nantucket were typically very independent and were quite able to take care of themselves. So that helped in her upbringing. She was named the first librarian of the Nantucket Library. I don't know how to say that word, Athenaeum, but it turns out I looked it up, that is just a library. She held that position for 20 years. Because libraries were not open for very many hours, limited operating hours, she was able to assist her father in many astronomical observations, and a lot of the work he did was for the Coast Guard. And she was able to also expand her own education. They worked in a small observatory that was on the roof of the Pacific Bank building. They only had a 4-inch telescope, but hey, a telescope is a telescope. She looked for nebula and double stars, and they produced numerous tables of longitudes and latitudes and altitudes of stars and things like that, which were very useful to the Coast Guard. In 1847, on October 1st, Mitchell discovered a comet using a 3-inch refracting telescope with a 46-inch focal length. The comet later became known as Miss Mitchell's Comet, named after her. On October 6, 1848, she was awarded a gold medal for her discovery by King Christian VIII of Denmark. Even though she did not have a college education herself, she was appointed a professor of astronomy at Vassar College by the founder of Vassar College. And she became the first female professor of astronomy. Mitchell became the first person appointed to the faculty and was also named director of the Vassar College Observatory, a position that she held for more than 20 years. Mitchell was the first international known woman to work as both a professional astronomer and a professor of astronomy after she accepted that position at Vassar. She also later became the editor of an astronomical column in the Scientific American. As a result of Mitchell's guidance, Vassar College enrolled more students in mathematics and astronomy than Harvard University did from the years 1865 to 1888. In 1869, she joined Mary Somerville and Elizabeth Cabot Agassiz, I don't know who that is, in becoming the first women elected to the American Philosophical Society. Hanover College, Columbia University, and Rutgers all granted Mitchell honorary degrees. That image at the top shows her sitting there. She's the woman sitting down on the left with one of her telescopes. And this telescope in that image on the top is the same telescope that's shown in the image on the bottom, which is in a museum in Nantucket. She had a very wide interest. She took photographs of the planets as well as the moons. She studied nebula, double stars, solar eclipses. She developed a number of theories around her observations, such as she developed a theory about how double stars revolved around each other and how the chemical compositions of stars were related to their colors. She heavily involved her students with her observations. She recorded sunspots in 1868 by naked eye, which is extremely dangerous, but anyway. She started taking pictures of the sun, and this allowed her to explore the hypothesis that sunspots were actually cavities rather than clouds on the surface of the sun, which is, we know that to be true today. She went to a solar eclipse and took assistants with her. She did very good with her students. 25 of her students would go on to be featured in Who's Who in America. In addition to the comet that's named after her, she has a moon crater. Mitchell was actually made National Women's History Month honoree for 1989. And she was inducted into the National Women's Hall of Fame in 1994. Okay, so I've done 3 women that had very interesting careers in astronomy, but prior to the middle of the 19th century. Any questions before I move on? Okay. Only 6 people here. What happened to Kay?
I'm here.
Oh,
just-
I see you. I'm sorry.
Yeah. Yeah. Vince was asking if any of them married. Those 3
Oh.
women.
I don't know.
I bet you not. I bet you they didn't.
Carolyn for sure did not marry.
Yeah.
I don't know. I don't think any of these women married. Some of the later women that I'll be talking about shortly, I'm pretty sure did. Oh, and that has to come up right now. Yep. My security scan stuff pops up once in a while. Okay. So I'm not sure. Funny, I didn't put that in here. Anyway, okay. I might have put it in some of the later ones that I'm going to get to now, but I'm not sure if I did. Okay. Then came along a gentleman called Pickering, Edward Pickering. And this is important, even though he's not a woman. He's very important to this topic. Pickering was a well-known astronomer in his own right. He had made several important discoveries. He was instrumental in the founding of the AAVSO. He had developed a method of acquiring spectra of many stars at the same time by using a special prism that would fit over the front of a photographic plate. Photographic plates at this time were about 10 inches by 10 inches in size, and he had a prism that you could put over the front so that every star on the photographic plate would get its prism put on the photographic plate. Nowadays, they use what's called an objective prism, which is the same thing. It's a prism that goes over the front of the telescope, and you get every star that goes in gets its prism put on the photograph. So this is what he had developed. In 1877, he was named director of the Harvard College Observatory. One of the projects, one of his pet projects, you might call it that, was he was doing a photographic survey of the entire visible sky, recording spectra, the proper motion of the stars, the brightness of the stars, and whatever else he wanted to do. And by 1882, he and his assistants, who were mostly graduate students, had captured images, including spectra, on more than 220,000 stars on glass plates. The problem he had was what to do with all that information, all that data. He himself clearly did not have time to do the analysis, nor did his assistants, basically. They were all, like I said, mainly graduate students or other professional astronomers that he had hired. And either the graduate students were working on their own classwork and their own agenda for their graduate career. The other professional astronomers that he had working for him also were doing their own research and their own agenda, and they certainly didn't want to sit down and do analysis for him. He tried to entice other professional astronomers from all over the world to come to HCO to do this work, but just like the assistants that he had there, they had their own agendas, their own research, and they were not interested in doing work for him, knowing that anything that would come out of it in terms of publications or anything like that would have his name on it and not theirs. They weren't going to get any credit for doing this kind of analysis work. So he didn't have any success doing that. He tried the graduate students from Harvard, but after using some of the graduate students, he found the results to be totally unreliable. The graduate students were too involved in their own studies and, in his word, flaky. He became so exasperated with one of his male assistants and efficiencies that he said even his maid could do a better job of copying and computing. So he wasn't very happy with his grad students. So he decided to use what the common term is, human computers. He decided to recruit women who were well educated in mathematics. This was one field of study that women had been able to get into by this time, was mathematics. There were plenty of mathematically educated women by this time. And also, he also knew that most women, even the well-educated women, they'd been trained in how to do routine, monotonous, repetitive tasks, right? They were all, even the women who were trained in mathematics had been trained in all of the, quote, women's work tasks. And so they knew how to do things that were repetitive and monotonous and so on. And also, he also knew that he could pay them less. Harvard College Observatory, like all other observatories, had limited funding. And so if he could save money in hiring women instead of men, he was going to take that into consideration. So he did that. Pickering's treatment of women during his time was considered better than most. They were, of course, underpaid compared to their male counterparts, and they typically were not given credit very often, but his willingness to include them in the world of astronomy certainly paved the way for many great female scientists and leaders. So Pickering, an important character in this story. During his years on the different projects where he used human computers, he would hire a total of 80 women from all over the world. And in fact, there were women mathematicians in Europe who asked him if they could work for him because they couldn't find any suitable jobs in Europe. And they knew that doing something for him was better than doing something for nothing anywhere else. And some women came from, Europe just to work for him, because after this project got going and he got these women going, results started coming out. And some of the women in Europe, some of the women mathematicians realized that this was a stepping stone to perhaps better things. So that worked. So good for Pickering. And by the way, every single one of the women he hired, all 80 of them, and I'm not going to cover all 80, I'm only going to cover a few, but all 80 of the women that worked for him as human computers, while they didn't all become fantastic astronomers, every single one of those women would go on to have impressive careers in their chosen field, whatever it was, physics, math, whatever. They would all have very nice careers after leaving Harvard College Observatory. So it was a stepping stone to better things. You've probably seen this picture before. I showed this picture when I did my talk on variable stars some years ago. But take a good look at this picture. This is Pickering's quote, what they call Pickering's theorem, but this is really what better known as, this is his first class of women that he had in his human computers. But take a good look at this picture. If you ever want to see a picture of great minds, this is the one. Out of this picture alone, 4 of these women would go on to make extremely fundamental, important foundation discoveries in astronomy. And the other 4 women would also go on to have very impressive careers in their chosen fields. But never before have you seen one group, one such small group of people make so many fundamental discoveries after they got together. I've just never seen that anywhere in science before. This is an impressive group of people. So let's take one of the women. The woman who's standing up in the background, Wilhelmina Fleming, 1857 to 1911. You remember that comment I made about that Pickering made about his maid could do better work than his grad students. This woman started out as his maid. She was hired into the Pickering household as their maid. Pickering's wife saw immediately that Fleming was talented in more than just maid work and suggested to Pickering that she be hired at Harvard College Observatory to perform some of the analysis work. Pickering would sit down with Fleming and instruct her on how to perform the analysis of the plates. And Fleming also went on and took classes and learned from the other women that were there at the time. She would work with Mary Draper and Annie Cannon on the Draper Catalog project. Eventually, she was named head of the project, which was a catalog of over 100,000 stars by spectral class. She developed a classification system that used hydrogen abundance as a way to measure the spectrum of the star. And this was later replaced by a system that we use today based on temperature. The first Draper catalog was published in 1890, and the majority of the work in the catalog was performed by Fleming. Fleming also made it possible to go back and look at older plates she organized all of the telescopic plates in a logical organization that allowed people to go back and look at earlier plates and do systematic analysis. In 1898, she was appointed curator of the astronomical photographs at Harvard. She was the first woman to ever hold that position. During her career, she discovered a total of 59 gaseous nebula, over 310 variable stars, 10 nova. The most notable discovery that people remember her for is she was the one who discovered the Horsehead Nebula using a photographic plate that had been taken by William Pickering, Edward's brother. Fleming is also credited with the discovery of the first white dwarf. In 1906, she was made honorary member of the Royal Astronomical Society of London. That was the first Scottish woman ever to be so honored. Soon after, she was appointed an honorary fellow in astronomy at Wellesley College. Fleming published her discovery in 1910, and she had other notable discoveries, including photographic study of variable stars in 1907, and spectra and photographic magnitudes of stars in 1911. She died of pneumonia in 1911, and there's a lunar crater named after her. All of this from his maid. And then now we're going to look at the Annie Cannon. This is the woman who's seated right in front of Fleming in that picture. Annie was the daughter of a Delaware senator. She did quite well in mathematics, and she attended Wellesley College, where she pursued undergraduate degrees in physics and astronomy. She studied under a famous woman astronomer named Frances Whiting, Sarah Frances Whiting. Physicist. She went on to become valedictorian at Wellesley College. She graduated with a degree in physics in 1884. She had a short career in photography in which she traveled Europe and used her box camera to take some pictures and published some stuff on photography. But around in 1893 or soon after 1893, she came down with scarlet fever, and that rendered her nearly deaf. In 1894, her mother died, and she wrote to her former instructor, Professor Whiting, to see if there was a job opening. And she was hired at Wellesley College. And then Whiting also inspired Cannon to learn about spectroscopy. And in 1896, Pickering recruited her and hired her as his assistant at the observatory. In 1907, Cannon finished her studies and received her master's degree from Wellesley College. Her first project at Harvard College was to help complete the Henry Draper catalog with the goal of mapping and defining every star down to magnitude 9. And she called it intensity, int, and so forth. Pickering said that she was able to classify stars very quickly. His quote was, "Miss Cannon is the only person in the world, man or woman, who can do this work so quickly." Soon after she started working for Pickering, Pickering decided that the catalog should also contain spectral classifications. There was a long argument between some of the women, Antonia Maury and William Fleming, about how they wanted to set up a spectral classification system. They had different ideas of how to do a classification. And Annie came up with a compromise that made both women relatively happy, using the Balmer absorption lines. And she was the one who created the modern spectral classes that we use today, O, B, A, F, G, K, M. She published her first catalog of spectra in 1901. In 1911, she was made the curator of the astronomical photographs, so she took over for Fleming. And in 1914, she was admitted as an honorary member of the Royal Astronomical Society. In 1921, she became the first woman to receive an honorary doctorate from a European university when she got an honorary doctorate's degree in math and astronomy from Groningen University, which I think is in Sweden. Cannon eventually classified more stars than any other person in the world. She totaled around 350,000 stars altogether that she classified. She discovered 300 variable stars, 5 novas, and 1 spectroscopic binary. And when she first started cataloging stars, she could do about 1,000 stars over a period of 3 years. But by 1930, she was able to do 200 stars an hour and classify 3 stars a minute just by looking at their spectral patterns. That's pretty fast. And her work was extremely accurate. She very rarely made mistakes in her classification. In 1922, the International Astronomical Union passed a resolution to formally adopt the Cannon stellar classification system that is still being used today. In 1922, Cannon went down to Peru to do stars in the Southern Hemisphere. And in 1925, she got an honorary degree of science from Oxford. In 1935, she created the Annie J. Cannon Prize, which is given out every year for the woman of any country whose contributions to the science of astronomy are the most distinguished. The award is still given out today. She became the William C. Bond Astronomer at Harvard University, which I guess is some honorary title. She would later collaborate with Cecilia Payne to show that stars were mainly composed of hydrogen and helium. She continued working at Harvard College until just a few weeks before her death in 1941. She is buried in Cambridge, Massachusetts. The American Astronomical Society presents the Annie Jump Cannon Award annually to female astronomers for their distinguished work in astronomy. And third woman in the picture, the one seated to the left of Fleming and Cannon, Henrietta Leavitt. And again, if you saw my variable star presentation a few years ago, you're pretty familiar with this woman. So Leavitt attended Oberlin College before she transferred to Harvard. And she received a bachelor's degree in 1892. Leavitt studied many things, but did not study astronomy. Finally, in her fourth year, she took up a course in astronomy and she earned an A-, and she got hired in by Pickering as one of the computers at Harvard Observatory. Her job was to measure and catalog brightness of stars as they appeared in the photographic plate collection. She became one of the curators of the astronomical photographs later. Leavitt left the observatory to make 2 trips to Europe and did some work as an artist. During that time, she contracted an illness that led to her going deaf, basically. She returned to Harvard Observatory in 1903 and started working with Annie Jump Cannon, who was also deaf, if you remember. Pickering assigned Leavitt to study variable stars in the small and the large Magellanic Clouds, as using plates that had been taken in Peru. She identified 1,777 variable stars, and she published the results in the Annals of the Astronomical Observatory of Harvard College, noting that the brighter variables had longer periods. In a paper that she published in 1912, she looked at the relationship between periods and the brightness of a sample of 25 Cepheid variables in the small Magellanic Cloud. She made a graph of the magnitude versus the period and determined that, in her words, a straight line could be drawn between the 2 series of points, showing that there is a relationship between the brightness and their period. And then by assuming that all the Cepheids in the small Magellanic Cloud were roughly the same distance, she could determine their intrinsic brightness and determine their apparent brightness, and she could get, what do you call it? She could figure out the scale on her plots that she made. And later on, some of the Cepheid variables, their distance could be measured by parallax methods, and that allowed her to set up her period luminosity scale and calibrate it so that she could use it to calculate distances for stars much longer distance away. This relationship between the luminosity of the Cepheid variable and its period allowed people to measure distances at much greater distances than you could using just parallax. This period luminosity relationship, now known as Levitz Laws, was the first standard candle in astronomy. It allowed scientists to compute the distance of stars way too remote for parallax. 1 year after Leavitt reported the results, Hertzsprung determined that the distance of several Cepheids in the Milky Way could be accurately determined. Cepheids, yeah, I keep saying that wrong. Cepheids were soon detected in other galaxies such as Andromeda and in Hubble, and they became an important part of the evidence that spiral nebula, which up until then were thought to be part of the Milky Way, but they became important evidence that spiral nebula, like Andromeda, were independent galaxies located far outside of the Milky Way. And therefore, Leavitt's discovery changed our picture of the universe, if you want to say it that way. It allowed Shapley to show that we're not at the center of the Milky Way, and then allowed Hubble to show that our galaxy is not the center of the universe. This method of using to accurately measure stars out to an intergalactic scale obviously helped us in our current understanding of the structure and scale of the universe. So it's a very important discovery. This is one of the fundamental discoveries in astronomy, in modern astronomy. Hubble often said that Leavitt deserved the Nobel Prize for her work, and the mathematician Gustav Leffler, actually the member of the Swedish Academy of Sciences, tried to nominate her for a Nobel Prize in 1925, but she had already died of cancer 3 years earlier, and the Nobel Prize is not awarded posthumously, so she didn't get a Nobel Prize. She does have an asteroid, a lunar crater, and a large telescope at the McDonald Observatory is named in her honor. Women seated at the extreme right in that picture, Antonio Mori. Mori, granddaughter of Draper and a niece of Henry Draper, wife of Marianne and Draper, all pioneering astronomers. So Mariana Draper funded research at Harvard College Observatory through the creation of the Draper Memorial Fund. As a result of those family connections, Antonio and her two siblings were exposed to science at a very young age. Maury's younger sister, Carlotta, would go on to become a geologist, stratigrapher, and paleontologist. Antonio attended Vassar College, graduating in 1887 with honors in physics, astronomy, and philosophy. At Vassar, she studied under Maria Mitchell. Remember Maria Mitchell? Antonio was one of 7 graduates to give an address at her commencement. So that's a big honor. In 1887, Pickering had found a spectroscopic binary, Mizar-A, and Maury was asked to determine its orbit, which she did using spectral analysis of the doubling of the lines to determine the period of a spectroscopic double. This was the first time that was done. In 1889, Maury discovered a second spectroscopic binary, Beta Aurigay, and calculated its orbital period. Okay. Eminent astronomer John Herschel recognized the importance of her achievements by writing to Pickering and asked Pickering to convey to Miss Maury congratulations on having with one of the most notable advances in physical astronomy. Very important. The Harvard Observatory at that time was using the classification scheme designed by Fleming and Cannon, and Maury found their classification system somewhat inadequate and developed her own. It was much more detailed and included information about temperature and about the brightness and intensity and so on. In 1891, Maury left Harvard College Observatory and started teaching at Gilman School. Pickering asked her to come back and complete her observations. She returned and published her observations in 1897. Spectra of bright stars photographed with the Levitz Draper. I love these long names of papers. Anyway, it presented the results of her examination of more than 4,800 stellar photographs using her own system. And she analyzed 681 bright northern stars in detail. It was the first observatory publication to have a woman's name in the title. Pickering and others, meaning some of the other women, had disagreed with Maury's system of classification of how to explain the line widths and didn't use it. But finally, in 1908, Danish astronomer Elsnar Hertzsprung, you remember Hertzsprung, realized the value of her classification and used them in his system of identifying bright red giant stars and faint dwarf stars. Hertzsprung wrote to Pickering that in his opinion, the separation by Antonio Maury of the C and the AC stars is the most important advancement in stellar classification trials since Vogel and Secchi. To neglect the see properties. It's the same thing as if a zoologist detected differences between a whale and a fish and continued lumping them together. So Hertzsprung thought her classification system was pretty good. And in 1922, like I said, the IAU eventually modified its classification system based on her work into what's known as the current system that we use in the Hertzsprung-Russell diagram, basically. Between 1896 and 1918, Maury taught physics and chemistry at a Castle School in New York. She also gave lectures in astronomy at Cornell. In 1918, Maury returned to Harvard as an adjunct professor with Pickering's successor, Harold Shapley, and she was given credit for her work, which she published under her own name. She stayed in the observatory until she retired in 1948. Her work summarizing many years of research on spectroscopic analysis on Beta Lyrae was published in 1933. She was a member of the American Astronomical Society and the Royal Astronomical Society. In 1943, she was awarded the Annie Jump Cannon Award in astronomy. There are a number of lunar craters named after her, pictured on the right there. All those Murray names on the left are named after her. So that's the honor you get, I guess, if you become a great astronomer, is you get a lunar crater named after you. Okay, so now we're no longer on that picture from Harvard College Observatory. We're not in the human computers anymore. We're getting a little bit beyond that. So this woman is not in that picture. She's a little later in time. Cecilia Payne Gapishkin. Okay. Born in England, she attended St. Mary's College, Paddington, where she was unable to study much mathematics or science. But in 1918, she changed to St. Paul's Girls' School, and there she studied science. She won a scholarship that paid all her expenses to Newham College at Cambridge University, where she read botany, physics, but eventually dropped botany. She started getting interested in astronomy after she heard a lecture by Eddington about his 1919 trip to the South Pacific to view a solar eclipse to help prove out Einstein's theory of relativity. That got her really interested. But she completed her studies at Cambridge, but was not allowed to receive a degree because of her sex. See what I mean about women not getting breaks until very late. Cambridge did not grant degrees to women until 1948. Well, so the only career she had in the UK was to become a teacher, which she didn't like. So she looked for grants that would enable her to go to the United States. She got introduced to Harold Shapley, and that got her into the graduate program in astronomy, and she left England in 1923. Come to America. Payne was only the second student to receive the grant. Shapley persuaded Payne to write a doctoral dissertation, and in 1925, she became the first person to earn a PhD in astronomy from Radcliffe College of Harvard University. Her thesis was Stellar Atmospheres, Contribution to Observational Study of High Temperatures in Reversing Layers of Stars. Wow. Payne was able to accurately relate spectral classes to their temperatures by using a theory called the ionization theory that had been developed by an Indian physicist. She showed that the variation in the stellar absorption lines was due to differing amounts of ionization, not to different amounts of the actual elements. So that's an important discovery. One of her results was that hydrogen was the most abundant element in the universe and the largest component of the sun. At that time, that conclusion had not been widely accepted. So that was an important discovery. A few years later, astronomer Otto Struve described her work as, quote, the most brilliant PhD thesis ever written in astronomy. How about that? Henry Russell of Hertzsprung-Russell fame also realized that she was correct, and he derived the same results using different methods. After she received her doctorate, Payne studied stars of high luminosity to understand the structure of the Milky Way. Later, she surveyed all stars brighter than 10th magnitude. She then studied variable stars, making over 1.2 million observations with her assistants. This work later was extended to the Magellanic Clouds, adding another further 2 million observations of variable stars. It's a lot of observations. She published her conclusions in her second book, Stars of High Luminosity. Her observations and analysis of variable stars carried out with her husband. Okay, so she was married. Got one. Laid the basis for all subsequent work on those objects. She was elected a fellow of the American Academy of Arts and Sciences in 1943. In 1956, she became the first woman to be promoted to full professor from within the faculty at Harvard's Faculty of Arts and Sciences. And later, with her appointment to the chair of the Department of Astronomy, she became the first woman to head the department at Harvard. So there's an important woman for you. Okay, we're getting a little more recent. We're almost up to date. Philadelphia, Pennsylvania, Vera Rubin. She started as the only undergraduate student in astronomy at Vassar College. How about that? All alone. She went on to graduate studies at Cornell and Georgetown. During her graduate studies, she studied the motions of 109 galaxies and made one of the first observations of deviations from Hubble flow, which is how the galaxies move apart from one another. She held a number of teaching positions in several universities. Eventually, she would work at the Carnegie Institute and was observing at Mount Palomar. Interesting side note, Mount Palomar at this time did not have any women's restrooms. She had to build one herself. She spent most of her career studying galaxies, their motions and properties. She investigated the rotation curves of spiral galaxies, beginning with Andromeda, by looking at the material outside. She observed the flat rotation curves that we now know are common. This was an indication that spiral galaxies are surrounded by dark matter halos. She further uncovered discrepancies between angular motion based on the visible light and the observed motion. Her research showed that spiral galaxies rotate quickly enough that they should fly apart if the gravity of their constituent stars was all that was holding them together. Because they stay intact, a large amount of unseen mass must be holding them together. So she was the first one to theorize, one of the first people to theorize the idea of dark matter. Her calculation showed that galaxies must contain at least 5 to 10 times as much dark matter as ordinary matter. Her results were later confirmed over subsequent decades and became persuasive results supporting the theory of dark matter, which had initially been proposed by Fritz Zwicky in the 1930s. Her research also prompted a theory called non-Newtonian gravity on galactic scales, but that theory has never been very widely accepted. Another area of interest for Rubin was the idea of counter-rotation in galaxies. She discovered that some gas and stars moved in opposite direction to the rotation of the rest of the galaxy. And this challenged the prevailing theory that all material galaxies moved in the same direction. And this was the first evidence for the idea of galactic mergers, which we know is something that happens. There's an observatory, the LSST Observatory is named after her. It's called the Vera C. Rubin Observatory. Her legacy was described in the New York Times as ushering in a Copernican scale change in cosmological theory. In 1996, she received the gold medal of the Royal Astronomical Society, the second woman to receive it after Carolyn Herschel received it in 1828. There's an area on Mars called Vera Rubin Ridge that's named after her, and there's an asteroid named after her. Okay. Now we're getting up to someone who just died last year. Margaret Burbidge. Burbidge. She studied at the University of College London, where she got an undergraduate degree in 1939 and a PhD in 1943. During World War II, she was the caretaker at University of London Observatory. Surprisingly enough, the wartime blackout made it easier for her to use the observatory's telescopes. That's funny. She was turned down for a postdoc fellowship at Carnegie in 1945 because the job required observing at Mount Wilson, which was reserved for men only at that time. Shortly after the war, she taught astronomy at University of London to undergrad students from all over the University of London system. And one of her students was Arthur Clarke. How about that? In 1951, she took a position at the University of Chicago Yerkes Observatory, Wisconsin, her first job in the United States. Her research during this period focused on abundances of chemical elements in stars. She went back to the UK in 1953, where her husband, so here's another one that got married, were invited to work with William Fowler and Fred Hoyle. You've all heard of Fred Hoyle, at the University of Cambridge. The team combined data on elemental abundances produced by Burbidge's with Hoyle's hypothesis that all the chemical elements might be produced in stars by a series of nuclear reactions, and Fowler's lab experiments on those reactions also. The idea became known as stellar nucleosynthesis. They published their model in a series of papers culminating in a magnum opus in 1957, now known as the B2FH paper, named after the initials Burbidge, Fowler, and Hoyle. I looked at that paper briefly. That is a well-known paper that talks about how the nuclear elements are created during the nuclear fusion process in a star. It's a really advanced paper, but it's an interesting paper. It's considered the best paper written on that subject. Margaret was the first author of the paper, which was written while she was pregnant. The paper demonstrated that most heavier chemical elements were formed in stellar evolution. The theory they developed remains the fundamental basis for stellar nuclear synthesis. Fowler was later awarded the 1983 Nobel Prize in Physics, shared with Chandrasekhar for his work on nuclear synthesis, and expressed surprise that Burbidge was not included. Well, in the 60s and the 70s, she measured masses and compositions and rotation curves of galaxies and performed early spectroscopic studies of quasars. And one of the discoveries she discovered was quasar QSO B1442 plus 101 at a redshift of 3.5, which is a pretty good redshift, making it the most distant known object at the time, a record which she held from 1974 until 1982. She was a supporter of the steady state theory, which I found interesting, but her own work on quasars helped to actually support the Big Bang theory. So interesting. In 1972, she became the director of the Royal Greenwich Observatory, a post that had never been held by a woman until then. And she has an asteroid named after her. And there is an award called the Margaret Burbidge Award of the American Physical Society that is given out annually. Now we're someone who's still alive and someone you've probably heard of before, Carolyn Shoemaker. She's got degrees in history, political science, and English lit. She didn't have any interest in science. So she married her husband, Eugene Shoemaker, who was a geologist. She took up astronomy. When she found out she had really good spectroscopic vision, which I guess helps. I don't know. Oh yeah, near Earth space, yeah. She started her career in astronomy in 1980 at age 51, searching for Earth-crossing asteroids and comets at Caltech. And she was using Palomar Observatory for those observations. That same year, Eugene was hired at the USGS as a visiting scientist, and in 1989 began working as an astronomy research professor at Northern Arizona University. She concentrated her work on searching for comets and planet-crossing asteroids. She teamed up with David Levy and identified the comet Shoemaker-Levy, which later ran into Jupiter. She has been credited with discovering or co-discovering 32 comets and over 500 asteroids. There is an asteroid named in her honor that was named in 1985. She received Scientist of the Year award in 1995. She received an honorary doctorate degree from Northern Arizona University in 1996 and received NASA's Exceptional Scientific Medal. In 1998, the U.S. National Academy of Sciences named both of the Shoemakers as the recipients of the James Craig Watson Medal. And I believe that is the last slide. Oh, and, oh, by the way, if any of you want to read more about the human computers at Harvard Observatory, this is a wonderful book. How do I end sharing? Oh, do that over here. Stop sharing. This book called The Glass Universe, written by Dava Sobel, D-A-V-A-S-O-B-E-L, is a really good book, and it talks all about the Harvard computer girls that worked at the Harvard Observatory. And about their numerous discoveries, and there's some nice photographs in here. It's available in hardback and paperback, and I think on eBay it's like $10. We have a copy in the library. This is our library copy. So if you guys want to check it out, when we get back to doing in-person meetings and the library is open for business, it will be there for anyone who wants to check it out. Okay, that's it. I'll take questions now. If anybody's got questions or comments.
Yeah, Vince has a question.
Go.
Back to Henrietta.
Yeah.
In addition, she had a play written about her.
Yes, she did.
Silent
I
Sky.
couldn't find out the name of the Broadway play, but there was a play. You're right. That was it was basically about Henrietta Levitz and the girls at the Harvard College Observatory.
Yeah, it was
Right.
called Silent Sky.
Silent Sky.
Thank you. I didn't know the name of it. That's why I couldn't find it. Thank you very much.
And
And it was Arizona Theater Company put it on a couple of years
Yeah.
ago.
Yeah.
Yeah, it was playing here in town.
yeah, a bunch of us went from TAA. Hey.
Right. I couldn't remember the name of it. I'm sorry.
Okay, one more. You mentioned.
Hi, Doug.
Wait, Vince is still asking a question.
Yeah.
Okay, you
This is
mentioned.
Kathy.
Oh, okay, damn it.
Oh,
Okay. You mentioned astronomer named Shapley.
Harlow Shapley.
Yeah. Now his son, Roy, he died here. He won a Nobel from economics. He was upset because he thought his father deserved it. But on a personal note, I actually worked with him and some of his students when I was at the Rand Corporation.
Oh, wow. Very good.
On this satellite, synchronous satellite treaty.
Yeah, he's an impressive astronomer in his own right.
Well, at age 92, I know that.
Hi,
Yeah.
Doug.
Yeah, go ahead.
Kathy Anderson.
Okay. Hi, Kathy.
Hi. Carolyn Shoemaker died a few months ago.
Oh,
at
I
the
didn't
age
know
of
that.
92.
Okay, I didn't know that.
Yeah, it was announced at the Astronomical League convention.
Okay, Wikipedia doesn't have that yet. Or at least they didn't when I put this together. Okay,
August 13th.
okay, yeah, pretty recent. Okay. Anyone else? I found this a really fun presentation to do. I learned a lot about these women, and it's like I could have done a lot more, especially the women that came out of Harvard College, those 80 women. They all had, every single one that I looked up had impressive careers after they left Harvard College. They all went on to do wonderful things in various different fields. So it's like good for Pickering and his group.
One more comment.
Yeah.
Now, women computers, were not new. Well, we had the ones in
In NASA.
Huh?
Yeah, hidden figure.
in the movie. Anyway, but Gauss and Euler, I know both used women computers
Oh, I didn't know that. Okay,
to do their calculations.
very good. I didn't know that. I know NASA did it. The movie Hidden
Yeah, what?
Figures, they used human computers for the early Mercury program. I didn't know Gauss and Euler did that, but it doesn't surprise me.
Well done, Doug. You put a lot of time into that.
Wow, interesting.
Thank you very much, Doug.
Okay,
And with
so
that,
there you go, Kay. You can do great things. See?
and with that, I'm going to go ahead and stop the recording for the night.